Okay, so let's see why this is true, if we can. I'm going to talk about only when x is bigger than or equal to 0 and y is bigger than or equal to 0, so we can make the analogy with those lengths, okay? And also we don't have negative square roots then or anything like that. So I'm wondering if this is true. Is x plus y over 2 always greater than or equal to the square root of xy? So let's multiply by 2. Is x plus y always greater than or equal to 2 times the square root of xy? What should we do now?
We could square everything.
Yeah, because we know everything's positive. That's not going to goof up any of the inequalities. So what is x plus y squared?
It's x squared plus 2x squared plus y squared.
And the question is that greater than or equal to, what's 2 times the square root of xy all squared?
It's 4xy.
4xy. And now I can just subtract 4xy from both sides and get x squared minus 2xy plus y squared. Is that always greater than or equal to 0? Okay?
Yeah.
Sorry, I'm just looking to see if this actually was on screen, which I probably should have looked beforehand. So it all boils down to, is this equation always greater than or equal to 0 when x and y are greater than or equal to 0? How can we think about that?
Well, if x is bigger than 0 and y is bigger than 0, we could try it for like a specific example.
Okay.
Like we could say x and y were both 1.
Alright. 1 minus 2 plus 1, which is?
Which is 0.
Which is 0. Okay.
So it is 0 if x and y are the same.
If x and y are the same, it seems like it's equal to 0.
But how would we do this in general?
Yeah. And this is what I wanted to show you, where the geometry gives some pretty good insight here. And the insight in the algebra is a tiny little bit harder.
Yeah.
Look at this equation now. It should remind you of something else that's written down on the whiteboard already.
Well, I mean, you can turn it. You can say that x squared plus y squared is x squared plus y squared bigger than or equal to 2xy.
Yeah, you could, but we've already moved stuff around and we have it all on one side. So look at this equation, or sorry, look at this piece of the equation. Does that remind you of anything that's already written down?
Well, it's almost the same as this part.
What is that part?
It says that x squared plus 2xy plus y squared is 4xy.
It doesn't say that. What does it say?
It says x squared plus 2xy plus y squared is greater than or equal to 4xy.
Yeah. Where'd that x squared plus 2xy plus y squared come from?
That came from squaring this.
So what is x squared plus 2xy plus y squared?
It's x plus y squared.
Huh.
So this one is x minus y squared.
This is x minus y squared. And why is x minus y squared always greater than or equal to 0?
Because we said that x and y are both greater than 0. So the lowest it could be is 0.
Why?
Because when you square something, we usually we're looking at positives. Well, when you square something, it's always positive. Right. At least if you square something that isn't like crazy, like I.
I, yeah. These are real numbers.
Yeah.
This is x minus y squared. And so x minus y squared, when we're dealing with real numbers, is always bigger than or equal to 0. So this interesting relationship that we saw from the geometry also has a very interesting algebraic relationship. The geometric one is easy to see the picture.
Yeah.
The algebraic one isn't super hard. It comes with recognizing forms of polynomials. And you say, hey, wait a minute, that's x minus y squared. That always has to be bigger than or equal to 0. And so that's really neat. And so that's 4 different lessons from this. 1 was about similar triangles. 2 was about turning geometric problems into algebraic problems. 3 was we learned how to construct square roots by accident. And 4 was this lesson about positive real numbers, that their average is always bigger than the square root of their product. Which is surprising. You wouldn't have thought that would always be true, but it turns out it is true. All right?
Yeah.
Pretty neat. Good job tonight, man.